Hi. So imagine a busy traffic junction in Bangalore during peak hours. Thousands of vehicles move simultaneously. Some riders aren't wearing helmets. Some vehicles jump red lights. Others drive on the wrong side, park lightly. Right? Maybe illegally, of course. The challenge is not capturing these violations. The challenge is reviewing them. Today, traffic enforcement still relies heavily on manual inspection of images, CCTV footages, reading number plates, like capturing from phones and just directly redirecting to an IC. So these kind of generating evidence, the process is slow, inconsistent, and expensive, and often inconsistent. That's why we built Trace. So Trace stands for Traffic Regulation and Analytics Continuous Enforcement System. So basically what we do, Trace is an AI powered LLM transformed into a machine learning pipelines have been made from 7 different things, from seat belt detectors to triple sharing to like violations of traffic rules, from everything to everything. So here how it works. An image first enters into our adaptive pre-processing engine. I mean, a video is what? A collection of images, like frame by frame is what image is. Suppose this is a car, it violating the traffic rules, right? So what it will do is, you can see that suppose your CCTV is connected. For example, just build this camera function, right? This is your car. It is violating a rule, right? What it will do, it will capture your number plate, that is OCR, by character recognition, and it will directly feed into your system on the basis of which it's been trained. So our machine learning algorithm will detect that, and on the basis of if it is violating the rules, if it is not wearing the seat belt. So we have made 7 different pipelines for further training of machine learning algorithms. Like you can use a new data sets to train the same model. So we have created a separate pipelines for further training of these data sets. So it will detect this and directly feed into our system that if someone is making violations, you can see on the basis of this confidence score, it will determine that, oh, this person is making a violation and let's issue a challan onto him. So you can directly figure out that the number of challans will be issued here. So you can see whose challan has been issued. So yeah, live monitoring is that how it will work. And on the basis of, suppose if someone making that, the image will directly come into it, and you can also like manually search that. An efficient net-based CNN, like convolutional neural networks, have been used for seatbelt detection, then analyzes every detected rider to determine helmet compliance and identify triple riding violations. Our unified violation engine evaluates all 7 required violations categories: helmet non-compliance, seatbelt non-compliance, triple riding, wrong side driving, stop line violations, red light violations, illegal parking, and from different other stuffs, right? For complex violations such as red light jumping, illegal driving, Trace uses a multi-frame tracking and camera-aware geometry. As I told you that, I mean, currently we have a less latency, like more latency, like 100 millisecond, but it could be reduced to 10 to 15 millisecond basis of how efficient GPUs we are using, how efficient hardware we are using. Okay. So once violation is confirmed, Trace automatically reads the license plate using OCR, generates an annotated evidence image, assigns a confidence score. So as I told you about this confidence score, right? This confidence score, like 81% to, and then what it does, it searches, stores everything, and betas on the basis of database. You can also download the CSV of this and send it to court, like this guy was making, and all these details are here. You can directly fetch them. So we built a full control room dashboard featuring live analytics. As I told you, the fully functional dashboard. The numbers validate our approach. I mean, we have created our license plate detection model, achieved a map 0.5 score of 0.86 and a map 0.5 of 0.96 on the basis of labeled holdout data. All 17 deterministic violation rule-based tests have been passed successfully, and complete system includes more than 60 automated tests running across Python 3.1, Python 3.10 to Python 3.12. The platform currently processes a frame in approximately 2.4 seconds that have a latency of around like 90 to 100 milliseconds on CPU, but as I told you, if you have a good infrastructure, good hardware, this will reduce to 2.4 seconds. So our vision is very simple: to help cities move from manual traffic monitoring platform or intelligent to an intelligent, scalable, and evidence-based driven platform. So trace transform images into insights, violations into actionable evidence, and traffic data into safer roads. I mean, every video is a combination of frames that are images. So yeah, that's how it works. So that is what the trace was. Traffic regulations and analytics for continuous enforcement. We are a team from HPTI Kanpur. I'm Prakhar. We have 3 other members, Adit, Pratik, and Madhav. So Madhav is the machine learning guy, and I'm the person who is built the pipelines and infrastructure and system design for this overall platform. Thank you so much for viewing our presentation. Thank you so much.